Good morning. Uh, Today we are again taking questions on function. This is a good question for us and it is an NCRT problem also. Uh, this question says, show that the function given to us, that is going from real number 2. This is real number 2. All the real number which are between -1 and 1, that means codomain is between -1 and 1, defined by fx is x by 1 plus modulus x is bijection. So we have to prove this function as 1, 1 on 2, and modulus is still there in this question. So now when we think about 1, 1 on 2 function, first we redefine this function. How we redefine this function? Just check. As modulus is there, so we'll say x less than 0. When you think about x less than 0, it will come x minus 1 by 1 minus x. When second will say it is greater than or equal to 0, I should say x by 1 plus x. And now we have to check whether this function is 1, 1 or not. That means two times we have to check this function is 1, 1 or not. First for this case and second for this case. When we take x1 and x2 less than 0, then we should check it is 1, 1 or not. And then second we'll take this. So we start with let x1 and x2. This is case 1 I am taking. Let x1, x2 belongs to R positive. X less than 0, so R negative I take. R negative means less than 0. So such that, what condition I am taking? F x1 equal to f of x2. When I say fx1 is equal to fx2, I'll use this condition. It will be coming x1 by 1 minus x1 come out to be x2 by 1 minus x2. And now when you solve it, it will come x1 minus x1 x2. This will be x2 minus x1 x2. x1 x2 get cancelled out. You will get x1 comes out to be x2. So for R negative, we say yes, the function is 1, 1. Then we'll go for the second case when x1 x2 belongs to R positive, case number 2. When you have case number 2, again we'll take x1 x2 belongs to R positive, union 0 also. 0 also I'm taking it. Greater than or equal to 0. Then again fx1 is equal to fx2, so I get it x1 by 1 plus x1 comes out to be x2 by 1 plus x2. And now when you solve it, it will be x1 plus x1 x2, x2 plus x1 x2. Again this part get cancelled out, I got it x1 is equal to x2. So we will say it is valid for complete less than 0 also and greater than or equal to 0 also. Therefore what I should say, f is 1, 1. We have decided that function is 1, 1. Now we are coming on the second part. We should check whether this function is onto or not. So to just check onto, we will go by other way. Now again two cases are there, we should find out. Here in this case, we start with fx is equal to, that is the case number 1. Fx is x by 1 minus x, which we'll take as y. Fx is x by 1 minus x, will take as y. Now, if I take this condition, and now we'll take y. Y is between -1 and 1. So case 1, when we are taking, when we write this way, when y is between -1 and 0. When you have y is between -1 and 0, or you do other way, that is if you feel that is comfortable, you do that way. Y is here, then we'll go this way. It will come x will be equal to y minus xy first. We'll do that way. Then it will be, we'll take x on one side, so x plus of xy will be simply y. or I should say x will be y by 1 plus y. Is this clear? This case is there when x you have negative. We have already done. So now we have to check that whatever the value of y will place, it should come x negative. Now, when y comes between -1 and 0, when you take between -1 and 0, what you will find, you will get x will be y by 1 plus y. Y is coming negative number between 0 and -1, then it is clear that it cannot be, when you put it -1 here, y -1 and 0. -1 is included or not? 1 minute, I'll check the question. It is not included. Sorry, this is open. Otherwise, we'll fail here. This equal sign is not here. I've just taken less than 0 and greater than or equal to 0. And here it is not given. So we will say when y is between -1 and 0. I just repeat it. Question says x should be between -1 and 1, not including 1 and -1, because problem will come when we take -1 included, this come out to be infinity. So that cannot be possible. So that should not be in the codomain. So here in this case, now when y is coming some negative number, what about your numerator? That will be a negative number. What about this number? This will be -1 to 0. So this will come out to be some positive number, because this is a number which is between 0 and -1. When it is 0 and -1, it means it will be negative but less than 1. So that means this quantity always come out to be plus. And who will be bigger in this case? Just check here. Who will be bigger in this case? Because in this case, this quantity, for example, I'll say -1/2 is there. So I'll say -1/2 in the numerator. Denominator comes 1 -1/2. Right or no? So in this case, when you take it -1/2, between 0 and -1, when it is -1/2, I'll take numerator is -1/2, and then it will be 1 -1/2. When you solve it, it will be -1/2 by what it will come out to be? Simply half. Then this come out to be -1. -1 means this quantity will be a negative number. Right or no? This is coming negative. And we are concerned about x negative or no? Less than 0. Let's I'll take -1/3 this time. When you take -1/3, this will come -1/3. This will come what? -1/3, and this is 2/3. 3 and 3 cancel out. It is coming -1/2. -1/2 is again what you will say? Negative. So this quantity always come out to be negative. So what you should say, when y is between -1 to 1, we have x which is coming negative. So one thing we have decided, this is our codomain. Codomain says from -1 to 0 and then 1. When you take the numbers from here, when you put y from here, you will have a preimage, and that preimage will be coming negative. Right? So in that case, preimage come out to be what? Negative. And this preimage will be what? Again, we will say it's a negative number and between 0 and 1. So we are not concerned. We are saying this is a negative number. So we will say in this case, when you say -1 to 0, preimage will be the negative one. Now case 2, when I take case 2, x is coming greater than or equal to 0. When you do this, it will be plus here, then it will be plus here, then what? X plus xy is, now this result will be x is equal to y plus xy, and then when you solve it, it will come x minus of xy. So it will come out to be 1 minus y. And now second case, when I take y is between 0 and 1. Second part is 0 to 1. When you have y is between 0 to 1, what will be? You have x y by 1 minus y. When you solve it, y is between 0 and 1, the numerator come out to be plus. Denominator will be also plus. Right or no? For example, if I'll say 1/3, then it will be 1 minus 1/3. So 1/3 by 2/3 come out to be half. Yes, this quantity always come out to be a positive number. So what you will say in this case, when y is between 0 and 1, you have the pre-image as positive real number. That is not a problem. So that means what you should say from this, that whenever you have taken the value between -1 and 1, every time it will be having its pre-image in the real number. That will be first time it was negative real number and now it will be a positive real number. So real number is going to exist and it will never come out to be 0 because 1 we are not including here. In the previous one, -1 not included. So therefore what I should say, thus for all y, thus finally we'll write for all y belongs to -1 to 1, there exists x belongs to real number. Sometime it is plus, sometime it is minus. Therefore, f is on 2. Hence proved. And function is 1, 1 also, function is on 2 also. Hence, we will say function is bijection. On 2 we have already done, so we will say hence f is bijection. So this is another important question you should remember. Yes, this is another NCRT problem we have. Let A and B are two sets. Show that function is going from A cross B to B cross A. A cross B means a Cartesian product here. A cross B having element A1, B1, A2, B2. So this way they will be having elements and it is going from A cross B to B cross A now. This is our function and here the elements will come as B1, A1, B2, A2, that way. Now my question is, function is defined as f of AB, means A1, B1 or if I say the element is AB, then its image will be what? B. This is the question 6. Then you have to prove that it is a bijection. So just to prove this as a bijection, we'll start with the two elements. Let A, B and CD belongs to A cross B, such that f of AB come out to be f of CD. F of AB is coming equal to f of CD. When f of AB is equal to f of CD, what the image of this will come? This will come DA and this will come DA. And if this condition comes, I told you in the order pair, first element should be equal to first element, second should be second. So we'll say B will be equal to D and A will be equal to, sorry, this is D and C. So A is equal to C. And if it comes, what you should say, this implies AB is come out to be CD now. Because I told you A is equal to C and B is equal to D. So AB order pair I can write as CD order pair. So f of AB is coming f of CD implies AB is equal to CD. Therefore, what I should say, f is 1, 1 function. So function f is 1, 1. Now coming on to. In onto, what we should do here, just check. When we think about onto function, onto one thing is clear in this part. For all BA, which you take from here, belongs to B cross A, there exist. If BA is here, then automatically AB is present here. We are not, because these sets are same, A cross B and B cross A. So if BA is here, then AB should be there. So we'll say for all BA belongs to B cross A, there exist. AB belongs to A cross B, such that what is the condition we have? F of AB comes out to be BA. Every BA there is AB, and this is the condition of the function such that FAB is coming BA. Therefore, what I should say, F is on. So it's a simple question. You should know it, that every BA there is AB. So that means f of AB, BA is there. So every BA has AB here. So f is onto function that you can have. Very small question I'll take in this case now. 1 mark question is there. If set A is given as 1 comma 2 and function is going from A to A, my question is how many 1 functions are there? How many 1 functions are there? How many 1 functions are there? So just to check, it is 1 function. What I should have A it is, and this is A element is 1 2 and 2 1. Now when you think about 1 function, I told you different elements should have different image. So when you think about different element as a different image means if this element I'll take, it have two choices with us. One can have image 2 or one can have image 1. Two possibilities are there. This one can have two images. Either it can take 2 as an image or it can take 1 as an image. Then whatever the second element that has no option now, it has to take the remaining element. Why? Because this 2, if you take the 2 as an image, it will become many 1. So we will say this will have 1 image and this is again going to be 1 image. So we will say in this case, first element has how many choices? That will have 2 choices. Second element only have 1 choices. So there will be 2 type of functions are there. So 2 1 1, how many 1 functions are there? 2 1 functions are there. By the way, they say 3 elements are there. 1 2 3, here also 1 2 3. And if I say how many 1 functions are there, then this element has 3 choices. Any one can be taken. It can take 1 element, 1 as an image or 2 as an image or 3 as an image. Now, 2 will have only 2 options because whatever 1 has decided will not be taken by 2. So that second element has 2 choices and then third element have only 1 choice. So we'll say total 6 elements. So we will say 6 1 functions will be there. So this way you can decide how many 1 functions are there. If there are 4 elements, then I'll say 4 3 2 1. That way we'll be having the function. So next time we'll continue.